In this exercise, we're going to be discussing the different file types Inventor uses. Inventor uses several different file types to maintain relationships between the different parts and assemblies to keep everything straight. So if we look here on the screen, we have an assembly file, we have a standard solid part file, we have a sheet metal part file, we have an IPN or presentation view, and we have a IDW, which is a drawing view, just like the DWG drawing view. So we have several different files to work from. If we take a look at new, we can see all of these files, and this is the easiest place to explain their relationships. We have parts. You take multiple part files to make up an assembly. Those assembly files can have drawings, and so can those part files. And you could take the assembly and create an IPN or an exploded view to show how something should go together. It's also good for doing bills of material. I come over here and I look at this one. You can see I did an exploded view with a parts list or bill of material and ballooning. So you can see how that goes together and what part is what. It gives you a really good understanding. Out of the box, the default templates, we have the standard English templates. These are basically an ANSI standard or imperial templates. If we go over to the metric templates, you can see that you can load as many styles as you want in Inventor. There's like 12 or 14 different default styles. We have ANSI, we have DIN, we have BSI, GB, so if you do any Chinese stuff, ISO, JIS for Japanese stuff. We have all of these different standards. And then you come down through here and you can see, depending on what work you're doing, you have those. In my Inventor, I have mold design loaded in my machine, and then mine is from a factory design suite, so I have some factory design options in here as well. If you have yours from product design suite or standard Inventor suite, you may not have all of these. Great thing about Inventor is where these templates are located. If I tab over here to just standard file explorer, you can see here's my templates. So I can say new folder, infinite skills. And as soon as I do that, you can see it shows up here in my list. So if you want to have your own company standards, you can just create copies of these files and pre-populate them with your company name, your department name, anything that you want to pre-populate into these files, you can create that and drop it into your company file. So let's take a look at our files and kind of how they work here. So usually you start out with a part file. Part file is pretty straightforward. It's made up of different features. You'll notice when you're working in the part file, Inventor lets you select different features and faces. We'll talk about selection later on, how you can adjust this. But you can see that it understands that you're in this part environment. If you are working in a sheet metal environment, you open up the sheet metal part. Allows you to do things like go to flat pattern and do things such as flanges and bends and anything sheet metal related. This is where I came from, the sheet metal industry. And let me tell you, it's very powerful. It does as much as anything out there can do. Don't let anybody tell you that it can't. And it's an amazing product for sheet metal design. I really enjoy doing sheet metal design in Inventor. Beats the heck out of the old hand calculations we had to do back in AutoCAD. If you need to convert it back over to a solid model, you can go up here to 3D model, convert back over. If you drew a sheet metal part out as a solid by mistake, you can come over here and say convert to sheet metal. It's very easy to go back and forth between these different environments. You make up multiple parts, come in here to this assembly. You can see as I hover around the different parts in the assembly, it automatically highlights those and tells me, hey, that I'm in an assembly environment. You don't really care about the individual features. So when you are editing a feature in Inventor, you're at the part level. So think about it just like you would work on a real manufactured part. If I manufacture this, I'm not going to be machining out these holes after I put it together. I'm going to do it once it's all together. Now, if there is something that you hand drill, like a self-tapping screw you put in after the fact, so you don't want the laser or plasma or mold or whatever to put a hole in there, you can come up here and do a hole in the assembly environment. What that means is it does not go back to the part environment. So Inventor works just like you're going to manufacture something. So think of it that way. If I put something in after it's fully assembled, then that's where I need to put it. I need to put it in the assembly because that hole does not need to exist. Now, if you just need it for reference, if you just want to see where another hole is in another part, you still do that at the part level. You can double click on the part and come over here and see the different pieces. Or if I come over here, back to my assembly here, I can edit a part in reference to everything else. So we can see here, it's showing me where these holes are based on this other part. So I could project those holes into this part. And I have done that because you see this little marker over here in the browser. Looks kind of like a recycled marker. That basically is saying, hey, I projected something in from somewhere else. It's allowed me to bring that information from that other part into this part. When you get done, you hit return, and you go back to the assembly environment. We can also have notes in our assembly. So you can see here's the engineer's notebook. This one I copied and pasted in bill of materials. I copied and pasted in a picture. I could actually have engineering notes, calculations about that part. So you could save that information in here so you can remember what happened. And you can see that there's a lot of information in here. And so Inventor likes to break it up into these individual files. No file is more important than the other, but that relationship is important to Inventor. So you want to make sure you don't move these files out of the project file. Everything has to reside under that project file. And if you do lose a component, you will notice the browser will give you some kind of little funky thing basically saying, hey, I can't find that component, and it wants you to go find it. So next we can look at the drawings. And you can see in the drawing here we have a parts list, and it shows a presentation view. And a presentation view is nothing more than an exploded view. This is really good to show how things go together or things like parts list. I have one customer that builds custom cabinets, like the really architectural, funky looking things. And what he does is he uses a presentation view and automates it so that you have a little video that he emails out to his installer that shows them what order to put things together. So there's certain things that you have to put in before other things sometimes don't make sense, but you have to do it because that's the way it was designed. So you can actually create a little video of this going together and show somebody how it's supposed to look. And then you end up with a AVI file or movie file that you can email out to somebody. The other option in our drawing file is to create, a 3-view where you get sections and dimensions. And you get all this prettiness that Inventor can create. Like I said before, you can either use the DWG or IDW. Where this came from was Inventor originally only had the IDW because the DWG couldn't handle everything. But now the DWG can handle everything the IDW can. I like to use the IDW for my Inventor work just because it keeps it separate for me. I don't accidentally open it up in AutoCAD or something like that. But if you prefer to only use DWGs, it's your preference. Sometimes it just makes it a little bit cleaner if you have 2 separate files, just so you don't accidentally mix them up. It's not the end of the world if you do open an Inventor file in AutoCAD, but sometimes I do like to keep them separate just to make things easier. So you can see there's a lot of information there and a lot of different files. So take a look at the different files, double click on a lot of objects inside of a file to see what the relationship is, and see if you can kind of follow it down the rabbit hole, so to speak. And see what you can figure out with Inventor and see how powerful these file types are. And we'll go into more detail in further lessons. In this exercise, we're going to discuss creating rectangles. In Inventor, you now have 4 different ways to create a rectangle. You have a 2-point rectangle, 3-point rectangle, and then you have a 2-point and 3-point center rectangle. This is new to the 2013 product line. Let's take a look at the 2-point rectangle. As you create it, you just select the bottom left and the top right hand corner, or you can go right to left. You have the option of doing direct input, of telling it how big you want it to be by tabbing through the different sides. It's pretty straightforward with the 2-point rectangle. There's not a whole lot of options you can do there. 3-point rectangle. What makes this so powerful is we select the first corner, and this way we're actually selecting the bottom edge. So now we can create a rectangle that's on a bias. We're able to create this rotated rectangle on the fly based on the geometry we have. The next option we have for rectangle is a 2-point center rectangle. What this allows you to do is have a rectangle that is automatically symmetrical in both directions. Very powerful in your tooling, if you're creating a punch, even in sheet metal if you're creating a punch, to be able to create that center point exactly where you need it. And then the fourth option that you have with rectangle is a 3-point center rectangle. Very similar to our other 3-point rectangle, we select the center point first, and then we control the angle. If you know what the angle is, you can tab to it. Say I want an angle of 135. Then I can go back to the dimension and either drag and drop the dimension, or I can type something in. If I know that this is going to be a 24-inch by 135 there, pick with my mouse, and now I can create how tall I want the rectangle to be. I can either type it in, or if I didn't know, I could just pick. You can see it automatically gives us the construction lines for the angle of the rectangle, and then it gives us the construction lines to control the center point. What those are there for is that's how it calculates where the center of the rectangle is. They do this programmatically to make it easier for them. Rectangles are very powerful now because of this. And anytime you use a rectangle over line work in Inventor, there's not a whole lot of difference. What the rectangle is there for is to save you time in drawing. In AutoCAD, the rectangle actually uses different code than using the lines. So some programs didn't like rectangles and some programs required rectangles for like CNC programming. With Inventor, it doesn't really care whether or not it's a true rectangle or if it's something you've drawn out. This is just a quick way to save you a few seconds here and there and be able to eliminate the steps of having to go and make it symmetrical and constrain it to the center. This instantly gives me a way to draw something out that's constrained to a center point and be able to dimension it. In this lesson, we're going to be discussing guidelines for creating successful sketches. You can use several methods to create closed shapes. You can use tools such as rectangles, circles, polygons, or you can constrain sketch geometry so that separate sketch elements come together to create a closed shape. At times, you may need to create a sketch geometry that is not closed. For example, the path for a sweep or to create a surface. However, most of the time you want to create closed geometry. It's a good practice to make sure that whenever you're sketching that you always close your geometry. Some of the guidelines for creating successful sketching: keep the sketch simple. Do not fillet the corners of a sketch if you can apply the fillet to the edge of the finished 3D feature and achieve the same effect. Complex sketch geometry can be difficult to manage as designs evolve. Repeat simple shapes to build more complex shapes. In the earlier lesson, I mentioned that as a small child, you're taught to draw Mickey Mouse by drawing several circles over and over again, and you get the Mickey Mouse famous head and nose and eyes. It's the same kind of concept. We're going to use very simple shapes and build up many of them to get that repeated design. Use 2D constraints to stabilize the sketch shape before size. Use the default dimensions until the shape is stabilized. What this means is don't worry about precise input. Try to get the shape down and the rough design down before you start constraining it with dimensions. And then always try to use closed loops whenever possible. Here's an example of some sketching guidelines. The sketch on the left was created by using rough corners or square corners and then adding fillets and chamfers after the fact. The sketch on the right was created by actually adding the fillets and chamfers into the sketch itself. And you'll notice how much busier the sketch on the right is than the sketch on the left. The other issue with this is later on, if I decide I want to change those fillets or chamfers, I have to dig down and find out what sketch this part was made with. On a single object like this where you have one or two features, it's not that big of a deal. But if you have hundreds of features that make up a very complex part, it can be very hard to figure out what sketch fillets and chamfers are in, whereas the browser automatically gives you all the fillets and chamfers. And so you can actually filter down to just the fillets and chamfers and hover over each one to see which one you need to edit. It makes it much easier if you add the fillets and chamfers as a feature, not into the sketch. Now let's do an exercise to create a 2D sketch. When we get finished, we'll have a part that looks something like this. To start with, we'll click the New command. This time, let's use the metric IPT. Standard millimeters fine. Click on it, click Create. I have mine set up to ask me what plane I want to put the sketch on. You may have yours set up to automatically give you the sketch. If it's not automatically there, click on Create 2D Sketch. So now we're in the sketching environment. We're going to go up to the Line command. And we're going to come down here. We're going to just drag this line out. It doesn't have to be perfect. I want it to be about 25 millimeters. And I'm going to come up here and just kind of eyeball how big I want the circle to be. And then I am going to come down and make sure that it connects with the end. And I'm checking to make sure that I've got my parallel and my tangent constraints. And I'll come down and close it. I want it to look something like this. It doesn't have to be perfect, just something like this. To get you used to this, we're not even going to fully constrain this sketch. We're going to leave it unconstrained. Because right now, what we're concerned about is getting the geometric constraints, not necessarily the dimensional constraints. So let's hit right click, OK. Right click again, and say Show All Constraints. You'll notice everything looks good except for it didn't pick up the tangent constraint on the top. So I'm going to go up here to Tangent and add my tangent constraint in there. Finish. Now you do notice that it didn't automatically give me the tangent glyph, and that's because I have to hit F8 again or right click and say Show All Constraints to basically refresh those images and get that glyph to show up and show me that I have that in there. Once I get that done, that's all I'm concerned about. I want to make sure my geometry is in the proper shape now. And it is. So I'm going to say Finish Sketch. I'm going to go to Extrude. I'm going to extrude this 5 millimeters. Hit OK. Now I'm going to do a secondary sketch based on this first sketch. So I hit Create 2D Sketch. I'm going to come up and do a 2-point rectangle. My first point, I'm going to come and hover over the corner of the existing geometry that was automatically projected. When I get my green dot, I'll left click and I'll drag down. When I get down to this bottom line down here, you'll notice I get a different glyph. It's telling me that this is coincident to this bottom line, meaning that this rectangle is going to snap to this rectangle. And that's exactly what I want. I want to make sure I don't accidentally grab the center because I don't want it to be that big. Somewhere, I don't know, around 5 millimeters is fine. I'm not going to type it in. I just want it to be rough. Finish. I'm going to go to Extrude again. Here in the top. Select Extrude. And this time, I'm actually going to grab my arrow right here and adjust my height. You can see I can just drag it to about where I want it to be. I'm going to drag mine to about 7.5. You can see Inventor tries to pop into kind of some even increments here, and it does a pretty good job of letting me pick 7.5. Okay. And rotate it around and look at the front of it. And now I've created a primary and a secondary sketch inside this object. You can see how simple it is to sketch and build complex shapes from very simple shapes. Remember, keep it simple and try to build as many objects as you can into features, not into sketch elements. When I'm finished with the part, I'm going to go to Save. It's going to ask me what do I want to call it. I'll say 0209. Let's call it Guidelines for Creating Successful Sketches. You can call it whatever you want to call your part. And you could save it into your default test project file that you want to use. Done saving, close, and we're finished. In this exercise, we're going to be discussing constraints, specifically inference and persistent constraints. We've touched on this briefly, but I wanted to go into a little bit more detail because mastering the sketching environment is really about mastering constraints. And we've seen that when we start drawing a line, Inventor will automatically start adding constraints. We've also seen that Inventor will try to give us a temporary constraint, so to speak. We've seen how we can right-click and say, Show All Constraints, and see what is added for us automatically. And we've seen how to manually toggle these on and off and add them. But it's really important to understand the difference between inference and persistent constraints. In Inventor, we have the option of actually inferring constraints without keeping that constraint. If I were to start drawing, I get these constraints, and I can hold down Control and not keep them. But what if I want it to be perpendicular or parallel, but I just don't want it to remember that? Underneath the Constraint tab, I have the option to toggle on and off constraint persistence. What that means is, whenever I come in here and draw, and I see that it's parallel, or that I see that it's perpendicular, and I get done, and I go to F8 to show all constraints, those constraints are not there. Even though that it drew a parallel or perpendicular line, it did not keep that constraint. When you get into very complex sketching, and you want to be able to add flexibility to your sketches, then it's important to not have these completely locked down. For most new users, I highly encourage you to lock everything down whenever possible, but there are going to be times when you need to toggle this on and off. If you get into an environment when you're constantly toggling between persistent constraints and inferred constraints, you can right-click on the command for constraint persistence and say Move to Main Panel. And the same with inference. And there's one more that, if you use this a lot, I suggest you move all three of them at once. You have the space anyways, and it's persistent dimensions. What this means is, if I draw this over again, and I have constraint persistence turned on, whenever I hit F8 and I say Show All Constraints, you can see I have my parallel and perpendicular. You can see this one even grabbed this line over here. If I turn off constraint inference, it automatically turns off persistence. Why? Because that's basically Inventor's way of guessing what you're doing. That's the artificial intelligence where it's trying to guess what constraint you would want to use. If it doesn't even try to guess, there's no way for it to keep it. So if inference is on, but persistence is not, that means you get the constraint, but it doesn't keep it. If both are on, you get the constraint, and it will save that constraint. The third option that we have is persistent dimensions. Currently with this on, if I type in a number, and I hit enter, you can see that it automatically gave me a dimension, and this means that it's going to drive the sketch and tell it what to do. If I turned off persistent dimension, what this would allow me to do is type in a number and get that distance without locking it down. So in a situation where you may want to get a rough estimate of a distance into a sketch, turn off the persistent dimension and be able to get the rough size in there without locking yourself down with that dimension. For instance, I may want to come back later on, even though I wanted this to be 1 inch to start with, and tell it that this really needs to be the dimension down here, 1.75, minus 0.75. Either way, I get 1 inch, but if this ever changes, if I don't manually put this dimension in and tell it to reference this dimension, there'd be no way of it knowing. With that being said, if there is an existing dimension there, I can take and use that dimension. So if I do dimension display here, as I start sketching, I could say that D0 minus 0.5 is what the dimension should be. The reason I may not want to keep this as I sketch this out is because I may actually want to reference a dimension that is created later on. So if I have dimension 5 that I want this line to be referenced to, and dimension 5 doesn't exist yet, I can't type in d5 minus 0.5. So what I would do is I would sketch it out completely, I would add all the dimensions, and then I'd come back and add this dimension after I added the driving dimension. But at the same time, I may want to give it a rough estimate of what size it is, and that's where persistent dimensions come in. So remember, inference is kind of like O-snaps in AutoCAD, and then persistence is whether or not it remembers that parametrically. Now, just like O-snaps in AutoCAD, for those of you who are familiar with that program, you have the option of turning on some or all of those constraints. If I right-click and I come down to Constraint Options, I will actually get this dialog that asks me what constraints I want to leave on or what constraints I want to leave off. In AutoCAD, in the past, if you had all your constraints on when you were running OSNAP, AutoCAD would just go crazy and it would be very hard for the program to tell what you were trying to snap to. Inventor is much better at this. If you need to temporarily turn this off by holding down Control, that's one of the better ways of doing it. If there is something that gets in your way a lot, you can come in here and toggle one of these off. I suggest that you leave all of these on most of the time because Inventor will figure it out for us. That's where when we get into sketching, we can tell it what line we're talking about. If I clean the plate here and I start sketching, and I determine that Inventor is not using the line I want to use to reference, I can just come up and rub on it. We discussed this in an earlier lesson. You can see it remembers which one I was talking about. That's fine. I can say, no, I want it to be this line. Or no, I want it to be this line. And Inventor will actually change the focus. So there's not really a reason to turn off my constraints I want it to automatically apply, other than if I want to globally turn them off, manually place them later. For the most part, new users, I suggest you leave all three of these on all the time. And then whenever you're sketching, if you're running into issues, hold down Control to temporarily turn off constraint, inference, and persistence. The persistent dimensioning, I suggest that if you're typing in a number when you're drawing out a sketch, then that number is important enough that you need it to be in there. If it's not important enough to drive the sketch, then don't put the dimension in there to start with. Just eyeball it out, get it close, and then go back add the dimensional constraint later on. Remember that keeping it simple and reducing constraints whenever possible is the best way to create a sketch in Inventor. If you over-constrain it, it will get messy later on whenever you have flexibility or adaptivity turned on in other sketches.